Have you ever looked at your kitchen's aluminum foil and wondered, how is this made? Journey begins with bauxite, a reddish-brown ore that's the primary source of aluminum. Discovered in the early 19th century, bauxite is found in large quantities in tropical and subtropical regions like Australia, Guinea, and Brazil. The process of turning bauxite into aluminum is fascinating. First, the bauxite is crushed and washed to remove impurities. The resulting slurry is then mixed with a hot solution of sodium hydroxide, which dissolves the aluminum oxide in the bauxite. This process is known as the Bayer process, named after its inventor, Carl Joseph Bayer. The aluminum oxide is separated from the undissolved bauxite residues and then cooled, causing the dissolved aluminum oxide to precipitate out. This precipitate is then heated in a massive furnace to over 1000 degrees Celsius, driving off any remaining water and leaving behind pure white aluminum oxide, known as alumina. The alumina is then treated in an electrolytic process known as the Hall-Héroult process, where it's dissolved in a molten solution of cryolite, an aluminum compound. A strong electric current is passed through this solution, causing the aluminum ions to gain electrons and form pure metallic aluminum. This aluminum is then drained off and cast into large blocks or billets, ready for the next stages of the process. Precision is key throughout this process. The smallest error can result in impurities that compromise the quality of the aluminum. That's why stringent quality control measures are in place at every step, from the extraction of the bauxite to the casting of the aluminum billets. So we've seen how a simple aluminum ore transforms into pure aluminum. But how does it become the thin, flexible foil that we use? Stay tuned, because in the next scene we'll delve into the art of aluminum transformation. And don't forget to subscribe for more interesting facts. Transforming pure aluminum into foil is no small feat. It involves casting, hot rolling, and cold rolling. Let's delve into the intricate details of these processes. First, there is the casting process. It starts with molten aluminum, heated to a temperature of over 1000 degrees Fahrenheit. This liquid metal is then carefully poured into molds. These molds are designed to shape the molten aluminum into cylindrical forms known as billets. Each billet is a solid block of potential waiting to be transformed into the versatile material we know as aluminum foil. Once the billets are cooled and solidified, they move on to the hot rolling process. Here, the aluminum billets are heated once again, but this time to a lower temperature. This makes the aluminum pliable but not molten. Then, massive rollers apply intense pressure to the billets, flattening them into thin, wide sheets. This process is a delicate balancing act between heat and pressure to ensure the aluminum doesn't crack or warp. But we're not done yet. The sheets are still thicker than what you'd find in your kitchen drawer. That's where the cold rolling process comes in. The sheets are cooled down and passed through rollers again, but this time, the process is done at room temperature. The rollers squeeze the sheets, thinning them down to the desired thickness of aluminum foil. It's an incredibly precise operation. Even a tiny variation in temperature or pressure could affect the foil's quality. Throughout these processes, precision is paramount. It's what ensures the aluminum foil's strength and flexibility. Every step, every temperature adjustment, every pressure application is carefully calculated and controlled. Because in the end, we're not just making a material, we're crafting an essential tool that finds its place in kitchens, laboratories, and industries across the globe. Now we have a thin sheet of aluminum, but it's not quite foil yet. There are still a few steps to go. Aluminum sheets are strong and flexible, but they need a bit more refining to become the foil we're familiar with. This refining process involves the application of protective coatings and lubricants, which play a pivotal role in enhancing the performance of the aluminum foil. But what exactly do these treatments do? Protective coatings are applied to the aluminum sheets to make them resistant to extreme conditions. Think of it as a shield, a durable outer layer that protects the aluminum from harsh environments, whether it's intense heat, frigid cold, or corrosive substances. This protective layer not only ensures the longevity of the aluminum foil but also maintains its quality and integrity. Now let's talk about lubricants. Lubricants serve a dual purpose in the manufacturing process. Firstly, they aid in the rolling process, making it smoother and more efficient, and secondly, they prevent the aluminum sheets from sticking together, ensuring each sheet is individual and flexible. But that's not all. Both coatings and lubricants play a crucial role in preventing oxidation. Oxidation is a process that could potentially degrade the aluminum, reducing its strength and flexibility. By inhibiting this process, these treatments ensure that the aluminum maintains its properties and meets the high-quality standards we've come to expect. With these treatments, our aluminum sheets are almost ready to be called foil. But there's one last step to complete. We're now at the final stage of our journey: cutting, packaging, and distribution. The aluminum sheets, now thin and flexible, are ready for precision cutting. This process transforms these large sheets into the familiar foil we use in our homes and industries. The cutting machines, calibrated to a fraction of a millimeter, ensure each sheet is cut to the exact size required. This level of precision guarantees consistent quality across all foil products. Once cut, the aluminum foil is then packaged. The packaging process is designed to protect the foil from damage and contamination. Each roll is typically encased in a box, with the ends of the foil sheet accessible for easy use. This packaging not only protects the foil, but also provides a convenient dispensing method for the end user. After packaging, the aluminum foil is ready for distribution. It's here that our global network kicks into high gear, delivering these products to various industries and homes around the world. Whether it's for food packaging, insulation, or even art projects, our distribution network ensures that aluminum foil is readily available whenever and wherever it's needed. This vast distribution system is a testament to the importance of aluminum foil in our daily lives. It reflects the global reach of this versatile product, from the mines where the ore is extracted to the factories, stores, and homes where it is used. And there you have it, the journey of aluminum from a simple ore to the foil that plays such an essential role in our everyday lives.